Hi, my name is Jasmine Smith and I'm participating in Challenge 2014. This problem was from the Math 1000 list of problems, and the problem is the volume V of a sphere of radius r is given by the formula V equals 4/3 r cubed. A spherical balloon is being filled by an incompressible gas at the rate of 25 inches per second cubed. How fast is the radius of the balloon changing when r is 18 inches? So this is a related rates problem, and we'll use calculus to solve it. And basically the steps are: find the equation, which is the equation that's given, the formula that's given for the volume of a sphere, and that's V equals 4/3 pi r cubed. Second step would be to take the derivative of that equation. And the third step would be to plug in what is known, which will be 25 inches per second cubed, which is given in the equation, and this will be the rate of change of volume, so we'll make that dV dt, and you're given that when r is 18 inches. So that will be r. This is just basically so you can see it better. This is the balloon and the radius, so that would be r. Messy. R. Okay, and basically to start off, here is the equation again. And what you have to do, it's actually really nice because you only have two variables, so you don't have to find a third or express it. So based on the problem, we are looking for dr dt because we're looking for how fast the radius of the balloon is changing when r equals 18 inches. So dr dt is what we're looking for. And so first step, you take the derivative of both sides. So when you take the derivative, instead of using v prime, we'll do it in respect to time, which is how you have to do it. And that'll be dv dt. Well, basically, it would technically be times 1, which would just be dv dt. But you just bring the constants down, 4/3 pi, 4/3 pi. And then with respect to time, and then you would bring down that part. So you're left with dv dt equals 4/3. You bring the constant down again. And to find the derivative of this part of r cubed, it would be with the power rule, you bring down the power and then you subtract 1 times dr dt. Chain rule bringing that out. And then to simplify, you end up with dv dt equals 4/3 pi squared times dr dt. And you can reduce these right here, so, or the 3's. So you ended up with dv dt equals 4 pi times r squared dr dt. So at this point, again, this is what you're looking for here. And we're going to plug in what we already have. And we decided that dv dt was going to be 25 inches per second cubed. So that's going to be 25 here equals 4 pi. Radius, this we're looking for when it's 18 inches. So we're going to plug in 18 squared times dr dt. And here, just basically using a calculator because, 18 squared, so you're going to have 25 equals 4 pi times 18 squared, which is 324 times dr dt. Okay. Just keep simplifying down 4 times 324, that'll give you 1296 pi times dr dt. And then, of course, to isolate the variable basic algebra, 1296 pi, divide on both sides, and dr dt equals 25 over 1296 pi. And to explain what the actual what this answer means here, well, that's the answer. The rate of change when the radius is at 18 inches would be 25 over 1296 pi, and the units would be inches per second. That's all.